Good evening all. Myself, Neeraja Chandrasekhar, Assistant Professor in Civil Engineering at Mahaguru Institute of Technology, Kayangulam, Kerala. It's my extreme pleasure to present in the ASI National Conference on Development of Space Startup Ecosystem in India. Here is my first lecture contribution to ASI. Now I start with the presentation, and my presentation is on Big Bang Theory. As an introduction, Big Bang Theory is a theory that states that the universe began to expand from an extremely small, dense, and hot ball of energy. All the matter on the universe is a result of this rapid expansion. As the figure shows, there is a singularity shown in the figure, and from that singularity, the universe has been expanded. Now also it is expanding. And in the figure, it shows that the universe is emerged from a singularity. Singularity means a point of infinite density and gravity. Next, after the Big Bang, the force of gravity began to affect the matter shooting outward in every direction. And it resulted the evolution of hydrogen and helium, two most common elements in the universe. And this explosion took place about 14 billion years ago. And this figure shows that after the emulsion of or the expansion of the universe, the clumps formed huge clusters which became galaxies of the universe. And these galaxies are moving away from the center of the universe. And the astronomers believe that the Big Bang Theory leads to an open universe. An open universe means the galaxies will continue racing outward, and therefore the universe will continue to expand until all the stars die off. An open universe leads to total emptiness. And gravity is a force of attraction between objects, or it is the force of attraction between any two objects with mass. And gravitational force is weaker than the other types of forces, even though it holds the planets, stars, and galaxies all together. As I have said, our universe is expanding. That means it leads to an open universe or emptiness, complete emptiness. And these figures shows the various types of evolution of the universe. That means closed universe means that backs on itself. An open universe, that is in the case of our universe or the galaxies, is that open universe, and it is moving away from itself. Next is Big Bang cosmology. And the Big Bang model is based on two assumptions. First is that the Albert Einstein's general theory of relativity, and it correctly describes the gravitational interaction of all matters. And the second assumption is called the cosmological principle. And it states that an observer's view of the universe depends neither on the direction in which he looks nor on his location. The nature of science and Einstein's ideas are: our modern model of the universe emerged before there was any observation to test it. Einstein's theory of gravity, or the general relativity, was published in the year 1915, predicted an expanding universe. The observations that showed the universe was expanding followed in the year 1929. Further study of the motions of the galaxies by Edwin Hubble revealed that they were racing away from us and each other. This was a proof of an expanding universe, and it was provided in the year 1929. That's a continuous study of supporting the Albert Einstein's theory of relativity. But many people believe that the Big Bang is just a theory with no evidence to support it. In science, we know the word theory means an idea that is well established and supported by scientific evidences. Hubble's observations of galaxies moving apart from each other is one of the several lines of evidence that supports the Big Bang model. Next, we are moving to some of the evidences for an expanding universe. That means supporting the Big Bang theory. First is the spectrum of hydrogen gas, and it is the unique fingerprint of that element. And a hydrogen lamp is shown there. At the same time, another figure showing the red band or the spectrum is also shown below. And the above slide, that means a hydrogen lamp slide, and the next three following slides shows the observational evidence for the expanding universe model in the effect expansion has on the light we receive from distant galaxies. Here we see the spectrum of hydrogen gas lamp and take special note on the following on the way hydrogen atoms emit light at specific wavelengths. First, this is a figure of galaxy UGC 12915. That means the camera, and we see the same repeating pattern of lines in a galaxy, but displaced to the red. That means the spectrum is given below, and we can see different colors or varying colors, but it is more focused to the red color. That means the red shift is coming. Here is the spectrum for the fairly distant galaxy pictured in the upper left, and it has a lot of hydrogen that glows as an emission line in the spectrum too. But pay close attention to the location of the 656 hydrogen line. That means the red shift. The next few slides shows galaxies at further and further distances, as evidenced by their decreasing apparent size in their digital sky survey images, and notice the redshift as of their hydrogen line that we have already seen in the previous slide. This is another figure, and the greater the redshift, the faster the galaxy is receding. Here also the value from 656 is increased to around 659 or around 700. And the recession velocity shown is 15,400 km per second. And the redshift is caused by the expansion of space. That means all these are evidences for the expansion of universe or the galaxies. That means supporting the Big Bang theory. Here also the value is increased from the redshift to another band, and the recession velocity also increased, that is 31,400 km per second. Next is the redshift is evidence for an expanding universe again, and it is increased, or the recession velocity increased here, that is 44,700 km per second. And testing the Big Bang model. Based on all these evidences, various studies has been conducted, and first one is the prediction done by Cecilia Payne, and the prediction was a hot, dense, expanding universe should be predominantly composed of hydrogen and helium. And the observations are universe is about 75% hydrogen, and other content is about 25% helium by mass. Composition of the universe from the above said study is the simplest of atoms, hydrogen, gets cooked into heavier elements at a high enough temperature and density, such as the cores of stars. In the early hot and expanding universe, this fusion process only has time to cook hydrogen to helium, plus a little lithium, before the expansion and cooling shuts down the nuclear furnace. All elements above helium in the periodic table are created in the life cycles of stars. And the theory is 12:1 ratio hydrogen to helium by number, or 75% or 25% by mass from the Big Bang. And exactly what it was observed is same. And the chemical composition of stars was determined by Cecilia Payne in 1925. And the composition of objects in the universe is one of the several lines of evidence that supports the Big Bang model. Another study supporting the Big Bang model was, and that prediction is, an expanding universe is evolving over time. If we look at the early universe, it should appear different. And the observations from this study was distant galaxies less evolved physically and chemically. Looking out into space is looking back in time. Distant galaxies therefore appear as they did in a less evolved universe. And these early galaxies are more disturbed because of collisions with other galaxies, smaller and contain fewer heavy elements. And heavy element is an astronomer's expression for all elements other than hydrogen and helium. Another study was the observation of another study done by Vera Rubin is 90% of matter is an unknown form. That means dark matter. A new and unknown form of matter exists, but its gravity works the same way and its presence is needed to explain how the universe looks. Here, 90% of the matter in and between galaxies is of an unknown form that does not emit or absorb light. It can be detected through its gravity by the way it affects objects we can see. And dark matter was first detected between galaxies by Fritz Zwicky in the 1933 and in galaxies by Vera Rubin in 1978. And without dark matter, normal matter would have been unable to clump and form stars in galaxies and us. Microwave background radiation means a faint afterglow left over from the Big Bang, and it allows the scientists to reverse the Big Bang and look back to approximately 3 lakh to 4 lakh years after the Big Bang. Another testing, the prediction was, if the universe was denser, hotter in past, we should see evidence of leftover heat from early universe. And the observation will be leftover heat from the early universe. And this study was conducted by Penzias and Wilson in the year 1965. All these studies supported the Big Bang model. Continuation of that slide, if you run the expansion of the universe backwards, there comes a time when the universe becomes very hot, dense and opaque, like living inside the sun. The light from this time, that is 13.7 billion years ago, still bats the cosmos. Originally at 3000 Kelvin, it has now cooled to 3 Kelvin and can be detected by the sophisticated radio telescopes such as WMAP, that means Wilkinson Microwave Anisotropy Probe. Like Hubble's observations of galaxies moving apart from each other, the discovery of this leftover heat is another line of evidence that supports the Big Bang model. And from the conclusion of the presentation, the theory of the Big Bang, as modified by the inclusion of dark matter or cosmic inflation and dark energy, is still the best explanation we have for the origin of universe. Several studies that supported the Big Bang done by several scientists and all. And however, there are still gaps and inconsistencies in our knowledge, and perhaps the nagging suspicion that the more we learn and the more questions we answer, the more there is to learn and the more new questions arise. So, here I conclude my presentation on Big Bang theory, and thank you.